Okay. Welcome to lecture 10 of MA 221. This is about surface area and how to calculate it. So suppose I have a function which is like this, y is equal to fx. Okay. And then in 3 dimension, if I kind of rotate this curve, say along this line segment from A to B on x-axis, then I'll sort of get something like a glass sort of structure, right? The surface will be something like a glass, and we are sort of interested in how to calculate the surface area. Okay, this is the problem that we need to deal with. Okay, so let me write the goal. So goal is to find, okay, okay, so the goal is to find the area of the surface obtained by rotating the curve y equal to fx, where x varies from A to B about the x-axis. Okay. So a little bit theory behind this will be like this. So if I just take a very small, thin strip here, say this little nudge is like ds, and also, okay, whether I just draw it like this. And see if I draw it here again, then it'll be sort of like this. Right? Say this is sort of like a circle, right? So this is like radius r, and this thickness is like ds. What we can do is we can open out this strip. Then it'll look like this, right? Just a sheet where 2 pi r is this length, because that's the perimeter of the circle, right? And this length is ds. Okay, so therefore the surface area of this little portion of the whole region will be dA, say area of this slice of surface, that will be equal to 2 pi r ds, right? And now the total surface area would be a integration 2 pi r ds, right? This will basically sum up areas of all these slices. Okay, cool. This is the basic theory behind it, but what I can say more, a little bit more I can add. So as x is varying from a to b, so this integration will be having limit a to b. And then 2 pi is just that. Now what is r? So if you think about r, then that r is sort of like varying along when you shift this little slice. So you have taken the slide here at the middle, right? If you move this slides towards right, say now your sheet moves to this, or your slice moves to there, then R also varies, right? So you can kind of think in your mind that the R should be basically Fx. Okay, there's a little intuition going on, so you can think about it more if you wish. Then R will be Fx. And now what is ds? Remember, ds is arc length, right? And we have the arc length formula, which I have derived before, is 1 plus f prime x square dx. Okay. So this is the basic theory that is going around. Just let me increase the brightness. Okay, so now the next thing will be, what if I rotate uh, about the x-axis, then how the surface area formula will look like. So if I say I have the curve, say this is y equal to fx, and say I'm rotating around x-axis, so therefore the area should be like this. The region will look like this. It's bad. We try to draw it better. Oh, something like that. And the formula for that we have already kind of derived it, 2 pi y ds. So here it will be 2 pi. Okay, so there are two cases actually. The first case is if the curve given as y equal to fx and x is varying from say a to b, then what happens is then your surface area formula becomes a is to be integration a to b 2 pi y square root of 1 plus dy over dx square and then dx, right? And if the curve given as x equal to say gy, where your y is varying from say c to d, some space, then your surface area formula becomes c to d 2 pi y square root of 1 plus dx over dy square and then dy. Okay, basically I'm using the two different formulas of arc length as I have discussed. This one is for this type of curves. This is the arc length formula, and this is the arc length formula when I have this type of curve. Okay, we'll look into the problems, and I think that then it will be like more easy to understand. Just add one more page here. Now the next question is, what happens when we rotate about y-axis? What is the surface area? Okay, for that, the picture should be something like this. Say this is my uh, function given, and I rotate around, say, y-axis, then the picture of the region will be like this. Because this time I am rotating around y-axis instead of x-axis. So now the formula will be 2 pi x ds. And here also I have two cases. If the curve is, I'll just copy paste. Okay, so if the curve is given as y is equal to fx, then the surface area formula becomes a to b 2 pi x square root of 1 plus dy over dx square, and then dx. And for the other type of curve, the formula becomes like a is c to d 2 pi. Now x is gy, so I can write gy square root of 1 plus dx over dy whole square dy. Okay, sweet. Now let me solve examples. So the first example, suppose that I need to calculate the area of the surface obtained by uh, rotating this curve. So this is my given curve, and I will try to get the area for rotating around x-axis as well as y-axis. Okay, so for A, the graph of this function y is equal to 2x is like this, 2 square root x. And now if I rotate around, say, x-axis at first, so this is 0 and say this is 3, then the surface that will generate is something like this. Okay, so I have to get the surface area of this region basically. Okay, cool. So now by our formula, what is A? A is basically 2 pi r ds, right? Okay, fine. Now I'm rotating around x-axis, so therefore I need to look at this formula. So now my curve is given as x, my curve is given as like this, right? Y is equal to 2 root x, so yes, it is this form. So I have to use this formula. Okay, so if I go back there, then I should have this to be equal to 2 pi y square root of what is that, 1 plus dy dx square dx. integration from 0 to 3. Okay, now we have to figure out what this is actually. This page, yeah. Let me just add one more page to this. Yeah. Okay. Now we know that y is 2 root x. So dy dx will be just x to the minus half, right? And then ds, rather I just write it down. Okay, so square root of 1 plus dy over dx square will be square root of 1 plus x to the minus half square, which is just square root of 1 plus x to the minus 1. Okay, now if I use this formula again, then it will be 0 to 3, 2 pi, y is 2 root x. Put that in, square root of 1 plus 1 over x dx. Okay, now the whole problem boils down to solving this integration. Okay, 2 pi times 2 is 4, 4 pi, so 4 pi comes outside of the integration. 0 to 3 square root x, and this will become square root x over square root of x plus 1 dx. This cancels. Then I have just 4 pi, and then if I do the integration, it will be x plus 1 to the 3 over 2 over 3 over 2 from 0 to 3. I guess I'm correct. So this is just 8 pi over 3 x plus 1 to the 3 over 2 from 0 to 3. And then that is same as 8 pi over 3. If I put 3 down, then 4 to the 3 over 2 minus 1, which is 8 minus 1 times 8 pi over 3, which is 56 pi over 3. Okay, and this is my answer. So I got the answer for rotating around x-axis. Now let's focus on B. Okay. So for B, I have the same sort of graph, but now I am rotating around y-axis. So therefore, the graph will be something like this. Okay, cool. This is not symmetric, but fine. Okay, so again, go back to rotating around y-axis, this case. And now I have the formula given as y to be fx. So I have to use this formula, y to be given as fx, and I'm rotating around y-axis. Okay. So if I want to use that formula, then I should be writing a is 2 pi, what's that? 2 pi x. So 2 pi x square root of 1 plus, I guess, dx over dy. What the other thing? Oh, dy over dx. Okay, so you have to be careful when you are just using this dy over dx square dx. I guess I'm correct. Yeah. Okay. So, and also, the function was given as y to root x. X is varying from 0 to 3. Okay, this lower limit and upper limit should be 0 and 3 respectively in this case. Okay, now again, we know that y is 2 root x and dy dx is x to the minus half. So square root of 1 plus dy over dx square is just square root of 1 plus 1 over x. Okay, one more page. Okay, so this now becomes 2 pi 0 to 3 x times square root of 1 plus 1 over x dx, which is just square root of x plus 1 over square root x times x, 2 pi in the front and then dx at the end. And this becomes square root x times square root x plus 1 dx, 0 to 3, 2 pi. This is 2 pi square root of x squared plus x dx, 0 to 3. And then to solve this, what we can do actually. Okay, so this is not too easy to handle, but what you can do is you can complete the square. Then you'll have x squared plus x is like x plus half square minus half square. And then you need to use trig substitution. As x plus half to be, say, half secant theta. So this is a little bit lengthy, but I guess you can solve it. Okay. This is not a bad exercise to like revise the trigonometric substitution and stuff. Okay, the next problem is you have to calculate the surface area of a sphere of radius r. We know that if I have a sphere, say like this, the surface area is given by the formula. Say this is of radius r is 4 pi r square. Okay, so let us verify if that is true or not. So how I can generate this sphere with just a curve in 2 dimension? If I say take this half circle and then I just rotate around, say, minus r to r, this segment on x-axis, then I'll get the sphere from there. Okay, but what is the equation of this half circle? X square plus y square is equal to r square, but your y is always bigger than equal to 0. Y bigger or equal to 0, that means you are not considering the lower part where y can be negative, right? Okay, this is basically a standard trick to like you know, consider the half circle or say, for example, I mean some portion of a standard graph. And now y will be then r square minus x square, right? Now then ds is, I know that 1 plus dy over dx square. If you calculate dy over dx from there, you'll get minus 2x over square root of r square minus x square, and then one more 2. So again, I need some blank page to add. Okay, then what happens is this is just minus x over square root of r square minus x square. Okay, cool. So ds will be square root of 1 plus x squared over r square minus x square, which is just r square minus x square plus x square over r square minus x square square root. This is basically simple, just calculation one after another. It'll be just r over square root of r square minus x square. Okay, so my surface area will be 2 pi square root of r square minus x square, and then r square root of r square minus x square dx from minus r to r. This is basically, for this I have just used the formula, okay, just like the previous case. And this will be 2 pi minus r to r dx. So I have r square over 2. So rather should have just taken something else. But oh, sorry. So this is 2 pi r and then dx from minus r. So just x from minus r to r. So this is 2 pi r times r minus r. Okay. Then that is basically 2 pi r times 2r. So 4 pi r square. So therefore it matches. Okay. Sweet. Okay. Okay, so for the next problem, this is given y is equal to 1 over x. So how does the graph looks like? The graph looks like this. And I have to consider from 1 to infinity. So it'll like carry on. So this is my sort of area under the curve now is. But then I have to rotate around, say, okay, the first question is you have to find the area under the graph. Okay, so for A, which is just take 1 to infinity, y dx, which is 1 to infinity, 1 over x dx, which is just, you know, this is improper integration. So you have to take t tends to infinity and then 1 to t, 1 over x dx. And that will be like ln t, right? Minus ln1. So rather I just do it in steps. Ln x 1 to t, and then limit t tends to infinity. Okay, so that is ln t and then limit t tends to infinity, which is just infinity, because remember ln is like this. So when you go very far along x-axis, then the functional value will be also very large. Okay, cool. So this is diverging. For B, I had to rotate the curve around x-axis. So if I rotate, then I'll have the graph will be like this. So I had to evaluate the surface area of this kind of bell-shaped region. Okay, so the formula for that is just 2 pi r ds. In this case, your r is just 2 pi y square root of 1 plus okay, it will be 1 plus dy over dx squared, I believe, and then dy, or rather dx. Okay. This is again, if I go back, then this is this formula. Rotating around x-axis, and your function is given as like this. So you'll use this formula. Okay, going back there, and then this will be 2 pi. What is y? Remember, y was 1 over x. So dy over dx is just minus 1 over x squared. So integration minus 1 over x squared, square root of 1 plus, oh, sorry, y. Y is what? Y is 1 over x. And then minus 1 over x squared whole square dx right there. And your lower limit should be 1, upper limit should be infinity. And if you carry on with that, then this will be like 2 pi integration 1 over x 1 plus 1 over x to the 4 square root dx 1 to infinity. Right. And then okay, so this is also pretty difficult to integrate. So I will just try to estimate it rather. This quantity will be bigger than 2 pi 1 to infinity 1 over x dx, because this is like a bigger than one value always. So I can just neglect that, but in that case I'll have this inequality. And you can easily see that this is infinity. So, and then I can argue like this, okay, this quantity, which is bigger than infinity, so obviously this will also be infinity. So therefore you can say that this diverges. Okay, cool. One more concept that I want to introduce, but I will not solve problem on that, which is rotating around other axis. Okay, so what if we rotate a graph like this, sorry, curve like this? This is y equal to fx around a line parallel to the x-axis. So in this case, I'm rotating the curve, or I am rotating the curve, but not on around the x-axis, rather around this axis. Then my graph will look like this. Okay, so this is A, this is B. Okay, okay. Then how my formula will be? So my formula kind of will stay same, just little different, 2 pi r ds. But here, so this line was y equal to b, right? Okay. So okay, so now if I think now this is my r, right? So r here will be the distance between the curve and this parallel line to x-axis. So here I can see that fx is big, so it will be fx minus b, right? This distance. Okay. So the formula will become something like that. A to b 2 pi fx minus b square root of, or I can say this is like y minus b, same thing. And square root of 1 plus dy over dx square dx, right? Is the, let's say that y is equal to fx, is highlight this. Okay, cool. And so say the graph is something like this time. So this is my y is equal to fx, and the parallel line through x-axis to x-axis will be like this, which is y equal to b. Then if I rotate around this line, then the graph that will be made out of this will be something like this, right? Now the r will be this, right? What is r now? R is just b minus fx, because now b is now kind of dominating above the fx curve. And then A will become just kind of similar, just a little bit different. B minus fx square root of 1 plus dy dx square dx. Okay, cool. And the second case will be, not difficult to guess. A line, if I rotate around a line parallel to the y-axis, right? Say, for example, I have fx as this, and the line parallel to y-axis is just x equal to d, say. Then the graph that will be made will be like this, right? Just varying from, say, A to, I don't know, this is the B. Then what is R? R is just D minus X, right? Remember, if we go back to the formula, a line, when you rotate around a line parallel to y-axis and your curve is given as y equal to fx, if I go back to the page where I have written formulas, you see that, yeah, for y-axis, I have this formula, right? The curve is given as y equal to fx, and then I am rotating around y-axis. So I have 2 pi x, okay, and then square root of 1 plus dy dx squared dx. This term will remain the same in the general case, right? So I'll just write it down. A will be 2 pi from, say, A to B, and this term is kind of fixed, dy over dx square dx. But there, when I was rotating around y-axis, I had x, but now I'm rotating around d, right? So therefore I should take d minus x in this case. Yeah, so this is all to be stated. Maybe what I can do is, like, I can write one problem, but I'll not solve. This is a little bit general. If you wish, you can try to solve it. Say, rotate the curve y is equal to e to the x from 0 to 1 about the following axis. And just set up the integration for surface area. Okay. So the axis is y is equal to -2, and say in the second case, axis is just x equal to 2. So basically you have to use these formulas, these two formulas, maybe. Let's highlight it. These formulas and that formula, maybe. And basically just have to set it up. Oh no, not that one. Maybe this one. Okay. Okay, so this is it for today. Yeah, if you have any question, doubts, solving the problems in the homework, you can meet me in the office hours. Thank you.